Hello, everyone. Welcome to the TMSI Expert Talks, the first one of 2021. My name is Leonie Terstegen, and I'll be your host for today. And I'm very excited about today's webinar because it's about our own Infinity Headcap. Can somebody please go to the next slide for the first slide, Peter? Yes, okay. Thank you so much. Well, today the webinar is about our Infinity Headcap, and I'm very excited about it. And of course, I want to welcome our speakers of today, which are Ronald de Vreeze from MFI. He's in the R&D. He's R&D manager. Further, we have Peter Aben, who's a business developer, also at MFI. And together with MFI, we closely collaborated to develop this headcap. And since they are our manufacturer, they can tell us all about this headcap and all the advantages. And also they will do a small demonstration. On top of that, we also have our own R&D engineer, Loek Gijben, who will explain the active shielding and also demonstrate the effect of active shielding on the signal quality. So welcome and thank you for being present. Before I give the word to Peter and Ronald, I would like to mention that as an attendee, your microphones are muted. So if you have a question during the webinar, you can use the Q&A button on the bottom of your screen and write your question. After the presentation, I will go through them one by one. Also, you can save your question for later, and then you can raise the hand button, and then I can unmute your microphone and I can give you the word and you can ask your question directly to one of our speakers. Last but not least, I hope you all enjoy the webinar, and Peter and Ronald, the floor is yours.
Thank you very much, Leonie. We are excited that we are in the position to present the Brainwave Infinity Cap, and we will talk you through all the steps we have taken to build the cap and what the advantages are for you in practice. Okay. Yep. So we will introduce the Brainwave Infinity EEG Headcap, in short, the Infinity Headcap, to you with the properties and the advantages. We will explain to you what are the specific aspects from the Infinity Headcap for TMSI and the cap you are going to use in combination with the Saga 32. We will elaborate a bit on the fabrics and the design of the EEG cap. The electrode specifics will be explained by Ronald. Then we will have a short workshop or demonstration how to use the EEG cap in practice in order to have an optimal EEG signal, and also that the lifetime of the cap will be as long as possible. And last, what Leonie already said is that Loek Gijben from TMSI will explain the aspects related to active shielding. So to start with properties and advantages of the Infinity Headcap, the properties of the cap related to the previous generation is that we have achieved an improving wearing comfort. We have chosen for very durable materials which support multiple cycle use, and we expect the cap to be used at least 200 cycles. The cap is very easy to clean, and we have chosen for a fast drying fabric on which we will explain later a bit more. The electrode positions are in contrast to the current cap, not printed on the electrode itself, but are printed on the fabric. Further, as you will later see, the flex swing on the inside is wider for an improved and stable EEG signal, and is also a bit softer than the current flex swing, which improves the comfort of using the EEG cap. The low noise wires are secluded or hidden between the inner and the outer lining, and that will have advantage, which I'll explain later in this slide. The advantages we see in this cap and what we have seen in practice is the ease and simplicity of the use of the EEG cap, the excellent and stable signal quality, and the optimal electrode positioning, up and running in shorter time compared to earlier generations of EEG caps. And the wiring is integrated in the caps, and that will prevent the risk of breakage or entanglement of the wiring in the EEG cap. So this is about the properties and the advantages. Now I will continue a bit on the specifics of the Infinity Headcap for TMSI. One of the eye-catching features is the print of the cap. In collaboration with TMSI, we have developed a specific print which has an exclusive look and feel, and gives you an advantage in the use of the cap. The cap material is water repellent, grade 4 out of 5. Grade 1 is actually, as you can see on the right-hand side of the slide, that kind of fabric absorbs water if it comes into contact with water, and the higher the grading of the cap is, the more water repellent the cap will be. In practice, that will mean if you clean the cap and you rinse it under the tap, that the water will purl off the EEG cap, and it makes you easier to clean, and of course that will lead to shorter drying times. Further, the material is breathing, and the breathing aspect of the cap, it's a kind of a cool max fabric like you see in sports clothing that will reduce the speed at which heat is built up underneath the cap. What you see here on the right-hand side is the EEG cap on a dummy head. That's, of course, the black EEG cap.
That's a 120 channel, 128 channel cap, as you see.
And what you see on the right hand, the right side is the cap turned inside out, and where you see the electrode housing with the silicone rings in it. The material of the cap has a 4-dimensional stretch, which means that if you place the cap on the head, that the stretch of the cap will be equal in all directions, which is obviously important, because if the stretch wouldn't be the same in all directions, then the electrodes would be dispositioned during the positioning of the cap on the head. And what I already shown is that the cap is printed, and it's a full color sublimation print, which gives the EEG cap an exclusive view. Some more aspects about the cap. The technical design is done in such a way that it's a uniform fit, which means that it will fit on most head shapes. And that uniform fit, and that will also support and optimize electrode contact, and also in the challenging zones like occipital on the back of the head or the temporal area, will offer more optimal contact for the electrodes so that your signal will be as good as it can be. Further, what you see on the demo model, and which you will see in the demo later on for the use of the cap, is that the ear opening is made in such a way that the ear doesn't come into contact with the seams of the EEG cap, and which reduces the risk of irritation on the ear. Especially when you have longer recording periods, you want the customer and the client to be as comfortable as possible wearing the EEG cap. It's a one-piece design, which means that the cap is made from one piece of fabric, and that only for making the two-dimensional of the one-dimensional flat plane into a three-dimensional piece, it's cut out of one piece, and the parts are welded together with ultrasound technology, so there is no overlap of the fabric. And that supports the comfort of wearing because it's a very smooth contact. Furthermore, the cap is very easy to apply. We have a chin strap with Velcro tabs, and you will see that in the demonstration which we will show you later. The cap comes in all standard sizes for adults, and the size indication is presented by the inner lining. The red cap you see in the picture is a medium-sized EEG cap, and the small cap has a yellow inside lining, or inner lining, and the large cap has a blue inner lining. And if you have an intermediate size, then it will be a combination of colors.
And these colors will also comply to what is internationally used with all kinds of caps. And so for your customers or your sellers, you can easily identify the caps by using the same colors.
Ronald, will you continue with the specifics?
Yep, okay. So standard, the caps can have 32 electrodes, or 64 or 128, depending on the demand. Of course, that will also result in more or less connectors. For the 32 connector of cap, it will be one connector, which is a LEMO connector. If you not already have seen it, it's a very fancy one, and it fits properly to the Saga recorder from TMSI, and offers a unique usability and by the push-pull system. So it only fits one way, and you can't mistake by putting it the other way around. It's very stable and very lightweight. For easy identification, we have chosen not any longer to have labels at the outside of the electrodes, but it is also printed on the cap. So there are highly visible. So that means even in dark circumstances, you will still be able to recognize the correct electrode positions at your head. And that makes it easier to use. And if you have more than 32 electrodes, then all the electrodes on the outside per group of 32 electrodes have individual colors, as you can see here. This is the 64 channel, which has for the 32 channel orange outside electrodes or gray. And as you can see in the picture previous shown by Peter, if you have a 128 cap, then it will be additional white and black electrode colors. And that makes it more easy to identify if there's any problem with an electrode for you. So that's easy. Let's see. The fabric is chosen because of the capabilities. It is very hygienic, and the properties of the product will help to reduce cross-contamination risk, but also the risk of pollution during use over time. Also, due to the water repellent characteristics, the material will not absorb as much as water as that you are used with the older caps or with other competitioner caps, because most of the water is repelled during washing and can even be shaken off once you have cleaned off your cap. Further, the cap material is very lightweight. It's also used in sportswear apparel, where, of course, these characteristics are very welcome, and we made use of that as well. So it's very lightweight material, but still durable and feels really strong. And the durability, of course, we have tested, and after even 200 cycles, we didn't see any wear or tear of any significant size. So that's good. Okay. Electrodes. Well, the electrodes actually is the part that makes your cap work. And we have chosen not to change the electrode as a material. So we're still using the DC stable AgCl chloride electrodes in the same dimensions. So there's no difference with the older cap because there was no need for to have that changed. But what we did is we changed the shape of the housing. That means that the previous cap had sharp edges or inside cavities, and that was not easy for cleaning, and nowadays cavities are more round and easier to clean. The height of the cap is also still the 4 millimeters, and that enables you to place the cap on the head and have right away stable contact, and so it's not really high. The flex ring at the outer side, which is the translucent part, or what you can see in the picture, that's what's touching the skin. It's a very soft material and feels very comfortable. Plus side of this material is that once the cap is perfectly placed, it also will reduce the spillage of gel to other neighboring electrodes, and prevents of forming bridges, which can of course affect your EEG recording negatively. Now that's already what I've told. I'm a little bit ahead on the presentations, but that can happen. And as you can see, it's nicely shaped, and no cavities where material can remain. And that's very important in these days because of all the challenges that we have right now. The connector I already told is a LEMO. There's a choice of TMZ. I think a very good one because it's very lightweight. It's plastic on the outside. It's medical grade. So that's what we also would prefer as a manufacturer.
Okay, so let's continue with the demonstration of the EEG cap and how to use it. In our experience, we found out that if we offer proper instructions in the beginning of the usage of the EEG cap, that will create better measurements. It will also support a longer life cycle of the EEG cap, which all is an advantage to you. And the comfort of the patient will improve if you do it the right way. And there are a lot of ways to do it wrong, but there is only one way to do it right. And Ronald is going to demonstrate that with me as a subject, the placement and the positioning of the head cap, how to position it correctly, administering the EEG gel, removing the cap, and cleaning and maintenance of the head cap, and a storing advice. I would like to make a note that it is also very elaborated, described in the instruction for use, which is added to the EEG cap, but we are very happy that we are able to give you a practical demonstration of the use of the cap in a practical setting.
Okay, so what we're going to demonstrate right now is just a quick way of how you put the cap on somebody's head. Peter, you can take off your glasses, please. Otherwise, we will damage that. Needless to say, but if you start an EEG with a person, you make sure that the person is healthy or at least able to conduct the EEG recording. The head should be intact, should be no visible defects on the skin. If so, I would strongly recommend not to use an EEG cap, but to use other ways of having an EEG recorded. For female and some male persons, it's important that the person has its hair not sprayed with any hair gels or conditioners or whatsoever, and the hair should be washed and absolutely dry, because otherwise this will influence the EEG recording significantly and the outcome is unstable.
Excuse me, Leonie, are you taking over the screen?
No, I stopped the screen sharing, so we have your full. You can have the full attention, and we have the full screen and not the presentation.
Thank you very much. Thank you.
You're welcome. Sorry, my apologies.
That's okay. Well, Peter has no long hair, so but should you have a person who has long hair, we advise to comb from the center of the line the hair straight down on both sides to avoid that any hairs overlapping each other, which makes it very difficult for you to see where the electrodes are properly placed. So that all said, you can start. Either you have a new cap and then there's less that you need to do. You can clean it if you want. We supply caps clean, but it's always wise to have it cleaned before, and that can be done with just some moist oil and make sure that the insides are all properly dusted off or any remains are there. Peter is my subject, so what we're going to do is we're going to ask Peter to relax and ask if he is okay, and if so, then we can start. There are many ways to apply a cap, and I will demonstrate the one that I have been taught and that we advise to our customers. First of all, it's very important to measure the head circumference. So that means that you measure from the front side over the ears, backside occipital, and then frontal again. That's your size for the cap. On the backside, you will find, besides the color coding, also an advised circumference of the cap that is to be used. If you are in doubt, always ask your supplier what will be the best advice. Sometimes you can deviate from what is in the backside, but it strongly depends on your situation. The red bar on the backside indicates in this situation that we have a red medium cap, but also, of course, as demonstrated earlier, you can see it on the inside. Now, once we have chosen our cap, then we can apply it to the person. To do it the right way is just fold the cap inside out and make sure that all electrodes are intact. This gives you also the moment to check if there's no electrode hanging loose or broken or whatsoever. If not, then you can take the frontal electrodes, FP1, FZ, and FP2, put them at the front of the electrode in the center, FPZ, and I will ask Peter now to hold the electrodes in position, and then roll off the cap to the backside gently, and make sure by using the hands and to push it backwards at the right position. The first indication of the cap is properly placed is if there are no electrodes hovering or tilted or whatsoever. In this case, that's not the situation, so we can proceed. Now it's important to check if the ears, maybe you can go turn a little bit on the right. Yes, thank you. As you see, the ear should be properly, the opening should be properly fit around the ear as it is here. And on the other side, it is as well. Now you can let loose. Yes, so we know for sure that this is properly placed. Now we're going to tighten the chin straps. And very important in this situation is because of the proper fit of the cap, it's not necessary to over tighten your strap. It's only to make sure that the cap is not moving around when the person is going to lay down or walking around. So one chin strap is placed under the chin and the other one is over the other side. And the little tab on the end, which is a Velcro tab, adheres to the material. Now you see the perfect placement of the cap. Is okay, Peter?
Yeah.
No stress?
No stress at all.
Okay.
No.
Great. So it's important now to have a quick look of if all electrodes are okay and if the cap is placed in the center. That's easily done by using a measure tape from the front side to the occipital side and divide the length in two and find the middle. That's always the black CZ electrode. If that's in the center, then your cap is positioned properly. For like this, the tilt on the head. Normally, if the ears are okay, then there is no issue. If you are in doubt, just measure the tape, place the measure tape around it and see if CZ is also from this line in correct position. All electrodes are now well positioned, and as you can see, the proper fit There are no air bubbles or electrodes that are hovering around. Every electrode is touching the skin properly. Okay, so now once that has been checked, we can start injecting the gel. On the market, there are a lot of gels available. We cannot recommend all. There are many that will suitable for this cap, but we advise to use one particular that I've been using over now 15 years, which is electrode gel. We have no any benefit of mentioning it, but it is a very stable product. It's readily available, and it comes with all kinds of accessories that you can use to top of your electrodes. Fill the syringe with enough of gel, but make sure that there are no air bubbles inside. Air bubbles inside can cause any problems later on when you have filled top of your electrodes. Filling the electrode is quite simple. Hold in one hand the syringe, use a blunt needle, very important, and carefully insert the blunt needle inside the opening of the electrode on the outside. Once you feel you touch the skin, retract a little bit, inject the gel, and move around a bit to make sure that all corners of the electrode are filled with the gel. I forgot one important thing to mention, and it is, of course, you need to connect your connectors to the device. Otherwise, you can't see if there's any contact to the electrode. Sorry for that, but switch on your machine, connect to the recorder, so you can see what happens if you fill the electrodes. So once you have filled them up, you can check whether you get a green signal or low impedances, depending on what your software you're using. And after that, if it's okay, you go to the next one. Sometimes it takes a bit before the electrode gives the perfect signal, but our experience is that it's only within a few seconds or a few minutes, and then everything is okay. So once you go over the whole head, you will see that in the front, the electrodes will be stable and have a good contact. And that ensures that everything is okay. If you don't have a good contact, probably you will have some air bubbles or not enough gel into it. Go to the electrode that is still not okay. Easy, because you have all the identifications around the electrode. Top off again the electrode and see what happens. If that is not still working, then you might want to lift the electrode a little bit to remove any air bubbles, or press a little bit. So manipulate your electrode until you see that the signal is okay. Afterwards, you probably need to top off your electrode again. Our experience is that this is really rare to do, but sometimes it's necessary, especially with people with a lot of hair. Okay, so now the electrodes are all filled and the EEG recorder says that all impedances are low. You can start your measurement. And during the measurement, depending on the time, we have persons who use it for sleeping recordings or long-term recordings. It might be necessary, depending on the gel that you use and the amount that is put into it, to top off again during the measurement. But normally it should be enough to last the whole recording. Once you have done your EEG, it's important to disconnect your cap again from the machine and then start removing the electrode of the caps. That's all the way around. So we're going to unleash the Velcro strap, and then we first make sure that the ears are free, and then from the back side we roll the cap like this, and then keep a hand in the inside, so that way everything on the inside is pointing to the outside. Now that you have the cap in your hands, you can decide either to lay it aside and wait for cleaning, or, as we advise, start right away with cleaning, because as long as the gel is still fluid, it's easier to clean than afterwards, because the remains of the material of the gel are very hard and very difficult to remove after a few hours or days even. Cleaning the cap can be done by holding the cap under lukewarm water tap with a medium flow of water. And what you actually do is you point the water to the electrode and make sure that it hits the inside, which will dissolve the electrode gel and washes it out. Of course, water will be spilled and gel as well. So afterwards, if you have done them all, you can check if there's any gel or debris still remaining and wash it out. Normally, if you do it properly and in a correct way, it should not be that much of a work. In the case that you still have gel remains, you need some tools to make sure that the gel is removed. Any gel stayed behind on the electrode afterwards will make sure that it gives you a bad signal because it's going to layering around the electrode, which disconnects it from the skin. There are many tools that you can use. I would advise to have these cotton swabs. You can get them in many shapes. We advise these, readily available. Just take out by turning slightly and make sure that everything is gone. If it's more deep or inside the cavity where you injected the gel, you even might want to use these toothpicks with a small brush on it. They go gently through the hole and you can push the gel out and make sure then afterwards, of course, rinse it again to remove it from the in or outside. If it is very tight and very hard to remove, you might even consider a soft toothbrush like for children and gently by rotating over the electrode, remove the last debris. Normally, my experience is that it's not needed if you do it right away. If you put it aside for a few days, then you certainly need to do it. You also can use the brush to remove any debris from the outside. But if you have not too much electrode gel in the inside, then probably at the outside, there will be no gel present. Okay, now your cap is a bit wet, which can be prevented, but not as much as that you're used. You fold the cap like this. You take a towel and dry off by putting it inside and gently pushing on the cap to make sure that the moist is absorbed by the towel. Then remove the towel again and have it air dried at a convenient place. Important with the air drying is that do not overheat by using hair dryer or put it on the heating which is placed under the windows. This will make the material less long lasting, and we have seen even that burn holes exist on the material. So just give it some time to dry on the air, and normally in the normal circumstances that will be fast dry. Other important part is because the water can transport through the sleeve, that you have the connectors aside from the connector and probably have it hanging higher as the cap itself. That prevents that water is going to penetrate from the backside into the connector, which could damage the signals or the inside, and that is the signal quality. After the cap is dried, you can put it aside or store in a plastic bag, whatever you want. In these days, we get a lot of questions for what about COVID and what do we do to disinfect? We have done some tests to see if there are any materials at the moment available for disinfection, and we have found a few. And one of these we have put into our instructions for use, and that's the incident foam. It's from a leading brand, so it's not somewhere bought, but this is a company that is specialized, and this product is also used for endoscopy and other difficult surgical instruments. You can just easily spray it over, it will evaporate very quickly, and your cap has been disinfected. We're also working at the moment for a new type of disinfection, which even can be submerged. And hopefully we can soon give our green light for this material, and that will be a major step forward in truly disinfecting caps from COVID. If you have used that material, of course, make sure that it is dry before you put it somewhat hot. Otherwise, it will affect the signals. So that's what is important about the placement of the cap on the head.
So this is the part we would like to present to you. Loek Gijben from TMSI will continue on the technical aspects of the wiring and the shielding and of the cap. We would like to thank you for your attention, and maybe in the meantime you can think about some questions you would like to ask us. They can be asked in this webinar at Leonie, and we will try to answer these questions as best as we can. Thank you very much for your interest thus far, and I'm very interested to see in what kind of questions you may have. Thank you.
Thank you so much, Peter and Ronald. Then I will now share my screen, and Loek can continue with the active shielding part. Afterwards, there are already some questions, so we will continue to the Q&A later. I will share my screen. There. 1 minute. And
I think you can do better. That's nice.
yes, it takes a while.
Okay.
Okay.
I can fully concur with what Peter and Ronald said about that it's fast in setting up and fast in cleaning, and that it's really comfortable to wear. I think the bullets who come flying in is here. Yes. I'm gonna show you what shielding and active shielding does to your signal, and how to eliminate cable movement artifacts and movement artifacts in general. And we're going to show you how it's done with the Infinity Headcap. We very much would like to do a live demo like Peter and Ronald do, but it's rather hard to have both a view on a video and on the signal. So I have prepared a nice video for this. I hope you can see it right in the screen. Over here we have one of TMSI's finest, that's Parham. And we've chosen Parham for EEG because we know we have a brain. He has a brain. He's a designated volunteer. You can see, I can stop the screen for a moment. I hope you can see my mouse pointer. We have used the 128 channel headcap, which is of course overkill for the demo we want to do here. And also we use it in common reference mode. And here you see the lead for the common reference, that's around the T from TMSI. And we did that for demo purposes. Normally you would measure in average reference. Right now we have 3 electrodes in the front, that's FP1 to FP2, and in the back that's O1 to O2. And especially the ones in the back is on an awkward place because there's the hole in the dent in your neck. And as you can see, we have really good, nice quality EEG. For demonstrating the effects of shielding and active shielding, it's not so nice to have a cap. So we've prepared a few separate cables. The first cable we're going to attach is an unshielded cable. So it has no shielding whatsoever. The second cable we're going to attach is a shielded cable, but it's not shielded with active shielding, but with passive shielding. The shield is connected to the patient ground. Then we're going to attach a active shielded cable, but it's just run-of-the-mill coaxial cable, and not the low noise cable we normally use at TMSI. And last but not least, we have our high quality, low noise active shielded cable. And we put it on the forehead of Parham. And so we can compare it with the FP2 signal. So I just leave the FP2 signal here, and we add the signals that are in front of the head. And I can stop the screen for a moment. The order is, the bottom one is the one on the cap, FP2. Then we have the nice low noise shielded cable, the active shielded cable without low noise, and the common shielded cable. And on top you see the unshielded cable. As you can see, there's a lot of 50 Hertz in the unshielded cable. And I want to ask Parham to use his eyelids a few times so you can get EEG signal inside your normal signal. And it's just for the scaling. You can see that the scaling is almost the same for the bottom ones. The top is even half the scale. So in actually the 50 Hertz interference here is twice as much as it looks on screen. That's nice. We want to focus on the 4 leads on the forehead, so we keep those 4 leads. The 50 Hertz interference here you can always get rid of with a notch filter. Of course, if there's 50 Hertz inside your signal, you also lose that part of your signal. But it's not only the 50 Hertz that is a problem. If you move the cable around in the electric field, you see enormous movement artifacts. And it's to a point that your signal almost becomes unusable. So I guess that's a nice indication that you don't want to use unshielded cables. We're just sitting in an average room with 50 Hertz. Then you have the 3 shielded cables, and the top one is shielded with an average, with a common shield, with patient ground. And I don't know if you could see it, but I couldn't see any difference. So what we did here was we increased the impedance of the patient ground electrode a lot. Like if your patient ground electrode would dry out a lot, then the impedance would go up. And then you can see that because of that, the electric field to the patient or to the subject, Parham, and that one to the amplifier will be slightly different. And you get a difference in electric field on both sides. Now the patient ground of the amplifier is now on a different electric field, and that's therefore you see a lot of 50 Hertz coming in. You can also see 50 Hertz in the active shielded cables, but as you can see, it's a factor 3 or 4 lower. So therefore we use active shielding. So we throw away the signal of the non-active shielding, and we get 2 active shielded signals here. The top one has no low noise measurements inside. I can explain to you about triboelectricity. If you move a conductor and an insulator over each other, if you rub them, you get triboelectricity. And it cannot go away inside your shielded cable. So that gives a lot of artifacts. So you have to make a special construction that generates not that much triboelectricity. And we can show it. This is the no noise cable. And if whatever we do with the low noise cable, you don't see any artifacts at all. Of course, you can still see artifacts if you start pulling on the electrode, and that's an electrode movement artifact. In fact, it was so hard that we pulled on this cable, and we still managed to move the skin under the other electrode as well a little bit. So therefore, we need a cable with low noise things, and we want to have a very lightweight cable, because if the cable is heavy and it's pulling like I did here on the back of the cap, you start pulling on the electrodes and you see some movement artifacts on this one. Actually, I think Manufactory did an excellent job in strain relief of that cable, because normally on another cap you would see a lot more electrodes having movement artifacts. And of course, the lightweight cable also must be with low noise coax. So it's a low noise pico coax cable. I just take all the cables together and I start moving the cables, and you don't see any artifact at all. So thank you, Parham, for doing this. And as I can see, I can still have a few minutes. I very much would like to show you another video we made, and that's for movement artifacts again. And let's see. That's this one. Now you can see that Parham is moving his head, and you might think, I see some slight movement artifacts, but if I make it still, it's because Parham is looking at a point on the wall and he's still moving his eyes. And also because we did the common reference measurement, it also has a crosstalk a little bit to the things on the back. And I thought, move your head, and I didn't like it that much, so we can do better. Just wait for it. And I guess this is why Parham doesn't like me anymore that much. And you can say, well, there's a lot of movement artifacts, but they're not. Over here, you can see this is EOG. And what you see here is artifacts from the neck muscles, and because he's laughing so hard, it's the jaw muscles. But you can see on the electrodes in the back of the head, there are hardly any movement artifacts. And I guess that's a big kudos to Manufactory for making such a nice cap. And that concludes my showing of why we want to use pico coax low noise cables on this excellent cap. And I think I will give the word back to Leonie, and I'm ready to answer any questions.
Well, first of all, thank you all for your wonderful presentations. I look for explaining active shielding and demonstrating it, and also the gentleman from MFI for demonstrating the new head cap and showing all the ins and outs. I wanted to give a short summary of like the benefits of this head cap. Like it really, what we are trying to do is providing the best signal quality. Like EEG, with EEG, it's very important, of course, to get the best signal quality because it's such a small signal. With this new head cap, really all the points of attention were on like improving the fit, long-term recordings, the difficult electrodes, which are often very noisy, like to improve all these things, and also like still being lightweight and being easy to use. So congratulations to you all for enabling this. There are a few questions. So I wanted to start with one of the cleaning questions from Mark van der Ruit. He's asking how well the fabric can be cleaned. In case there is gel spilled on the fabric, it is highly water repellent. Like one of the problems he has is that caps are starting to looking dirty, filthy because of the spilled gel. So I don't know if some of Peter or Ronald want to answer this question.
It's unmuted, huh? Yeah, you can hear me, huh?
Yeah.
Yeah, okay, well, that's a good question, of course, because that's always, pain in the ass to say so. And the fabric on its own, the way it is woven and how it is acting to dirt, it actually makes it very easy to remove the gel. The gel is actually not soaked into the fabric, but it's on the outside. So even if it is dry, you just by rubbing the fabric or using a very soft towel, you can just take it off. And if it is very persistent, if you have been not paying attention to it and it is already dried up over a few weeks or so, then you might want to first make it moist or wet under the water tap, and then remove it as I demonstrated earlier, and then have it, of course, dried again. So yeah, it's quite easy to do so. Yeah.
Okay, thank you for answering this question. Can you recommend some soap or anything that people can use?
Yeah, that's a good question.
remove
We
the
didn't
stains?
mention it in our instructions for use. We advise from the same brand as Electrocap. I don't have it here, but it is called Ivory. It's called dishwashing fluid. And it's very strong cleaning. We also have tested with Biotex, which is readily available here in Holland. Not sure whether it's over the borders as well, but it's a biodegradable washing detergent and very effective on enzymes. That can also be used. So, but I would stay away from any materials that hold large amounts of alcohol or any aggressive chloride materials, because that will adversely affect the materials in the end.
Yes, and it can also leave a little coating on the electrodes, right? If I'm correct.
Yeah,
that
well,
makes it harder to get a lower impedance.
Yeah, we sometimes see caps back that are complained is typically high impedances, and then we start checking the wiring, which is mostly perfect in order, but then we have a closer look at the electrode under the microscope, and what you see is some kinds of layers of the electrode gel that has been used and not thoroughly rinsed off. So yeah, it's very important not to wait too long with cleaning your cap after usage. It's the best practice and makes you use the cap for many years.
Okay, I hope this answers your question, Mark. Then we have another question from Srinivas. It's about the active shielding. He's asking, what is the difference between active and passive shielding? So I think that's a question Loek can answer.
Yeah, it's my bad. I should have answered that question in the presentation at first. Technically speaking, active shielding is you take the signal, you amplify it once, and you put that back on the shield. For layman's terms, it's better explained that you pick a signal on the screen, you do it through the amplifier, and the signal travels to a safe tunnel of its own signal towards the amplifier without any interference whatsoever. So you need an extra amplifier for each channel, and that's what it makes at least more complex. But also because the signal and the screen have the same voltage, the same level, there's no capacitance left anymore. And for EEG, it's not that important, but normally you get a low pass filter out of a passive shielded cable. And for EEG, the frequency band is low enough, but for EMG you could see some diminishing of signal quality. But in general speaking, because the signal travels through a tunnel of its own signal, it doesn't see any interference at all from the outside.
I hope that answers your question, Srinivas. Then I have another question from Locus. He or she is asking if it's possible to use EEG and FNIRS at the same time. Maybe that's a question I can answer. It is possible to measure EEG and FNIRS at the same time, although the NIRS are using optodes and they cannot be placed on this head cap. So we have a different head cap available for that. It has ring electrodes as well, but it also has the integration for the NIRS optodes. So you will require a different head cap for this one as well. So I hope that answers your question as well. I don't know if there are more questions. Let's see. Otherwise, I have maybe a small question for Luke, because I know some people prefer to use active electrodes instead of passive electrodes. I don't know if you can explain the difference and what is beneficial in this case.
Active electrodes instead of active shielding.
Oh yeah, I'm sorry, my
Yes.
apologies.
Well, foremost, at TMSI, patient safety is paramount. And using active electrodes, it's very hard to maintain patient safety because you have to bring your supply voltage to your active electrode on your head. And suppose one of the wires is breaking, which is a single fault condition, then you have to make sure that the current through the patient is limited, and it's limited to about 50 microamps. And to do that, we don't think it's impossible, but at least up to date, we haven't seen any medical certified Headcap with active electrodes yet. Compared to signal quality, in theory, with active shielding, you can get better results. In practice, I don't think many people will see many difference between a Headcap with active electrodes and active shielding. But then active shielding is inherently safer.
Okay, thank you for answering this. I see we're almost out of time, so I don't know, we are almost 1 hour further. So if there are no more questions, maybe I should bring this webinar to an end. I don't see any other remaining questions. So then I would like to thank our speakers of today for their time and their effort for this presentation, and also for all our attendees to be present and showing their interest in our new Headcap. Of course, if there are questions, you can always contact us at sales@TMSI or info@TMSI. The Headcap is available now, well, and we are here to answer all remaining questions. And we're looking forward to the new webinar. It still has to be planned, but we will keep you updated. Follow us on LinkedIn. There will be any updates about new webinars and new news. So yeah, thank you all, and have a nice day.
Thank you. Bye-bye.
Thank you very much.
Bye-bye.
Bye.